So we're going to talk about net zero buildings in an urban environment, dense urban environments and hot urban environments, which is sort of the worst possible combinations of all things in terms of the challenge. I'm Steve Selkowitz at the Lawrence Berkeley Laboratory. I'm a researcher. I've been working on building science for almost 40 years. You've got about 120 years of experience between us here. So it's, I was going to try to pretend I was 29, but wouldn't probably have gotten away with that. I've been at the lab for 40 years doing a lot of basic research, but the research is always targeted at changing what happens in the real world. I've partnered with John Kung and Kipo Lam for the last 3 or 4 years with Singapore, and you'll see some of the results of that. We're going to, let me get my slides going here. We're going to talk about the technical and the policy challenges here. And the way we're going to frame this is I'm going to lead off by kind of painting the framework for this, and I'm going to draw on my experience in California. I'm an advisor to a group in Norway, so I spent some time in Europe. I spent some time in Singapore, some time in the States trying to figure out where we are with net zero buildings and how to get them to be the ubiquitous solution out there. And then I'm going to be followed by John, who will talk about this very interesting program that Singapore is running. And they put all the pieces together that I'm going to throw out on the table and say, these are the challenges. John's got them arranged in a way that we think might actually solve the problem. And then we're going to sort of drill down to the practical realities of what you do in one building. And Kipo is going to give an example of what's going on in Singapore there. At the end of that, we'll have a Q&A session. We're going to take up only about half the time in speaking, and you'll have a chance to throw things at us. So not literally, I hope, but good questions. But before we start that, in terms of learning objectives that we hope you'll come away with, we wanted to find out a little bit more about who you are. So I have just 3 quick questions and ask for a show of hands. The first thing is just to identify who you are, what you do. So if you're an architect, raise your hand. Oh, well, okay. Engineer. Building owner or developer. A supplier, technology supplier one way or another. Policy. Okay, we're getting to the tail of the curve here. Anyone I missed that's really important? I mean, I know there's lots of other. Researcher, okay. I can relate to those. Good, thanks. Second question, how many of you have been involved in the design of a net zero project of any flavor in any way? That's great, okay. Now, here's the really tough one. How many of you have worked on a net zero building that has been built, is operated, and measured to show that it achieves those goals? Okay, great. So the 3 of us are going to leave, and we're going to invite you to come up and give this talk. Okay, let's jump in. So I'm going to kick off with this framing the problem. Mission impossible. No, it's not mission impossible, but it's a challenging mission. The image is here, Singapore on the right, Boston in the middle, and the suburban sprawl on the left. And one of the issues here is density and climate, just to sort of kick things off. Why are we doing all this? I mean, a whole lot of reasons. One of the things that resonates with me as a recent grandfather is a kid who will be around in 2100. This is a projection of what the coastline, Boston's up there in the upper right, might look like in the worst case scenario. Singapore has its own challenges as well. There is a pathway to stop this, and that's called reducing energy and carbon use. The goals that are needed in order to do that are pretty aggressive, and people look at 80% reduction and say there's no way to do that. Why do we focus on buildings? Buildings are a very big part of the solution and the problem. Roughly 40% in the US. I think the numbers are a bit different in Singapore, but it's clearly an area that we have to pay attention to. And the 80% piece looks tough, but if you break it into 3 simple parts, sort of rethinking how we use what I'll call energy services in buildings and cities, and then once you determine what services you need, you should deliver them in the most efficient way, work in high performance glazing and smart glazing and shading and LED lighting. And then finally, you are going to need real energy in these buildings, and you can provide that with non-carbon sources. If you chip away about 50% at each of the 3 of these, you end up with 80% reduction. So we have a pathway there. And the other concept I think most of you seem to know or be expert with net zero building is it's not just about putting as many PV panels on the roof of the parking garage as you can. It's about reducing the load down to the lowest feasible level and then supplying the rest of that with renewables. And this is a conceptual diagram that just shows how you might do that over time. The diagram is great. The problem is we're not quite making the progress. This is an older diagram you can see, and we're not at 2017 would suggest we're almost there already, and of course we aren't. But people have built successful buildings. This is one I visited. It's a great building in Seattle. Seattle's a fairly cloudy climate, and they went all the way. This is a medium-rise building, so it's a challenge. But given the fact that the climate isn't ideal there for solar, in order to get net zero with solar, they had to extend the PV canopy over the edge of the roof. So clearly, a number of buildings like this have been built, and the real question is, can they be replicated at scale? And a number of groups in the US are sort of tracking progress, and this is a good news, bad news story from my point of view. The good news is that there's this rapid increase in the number of buildings. There are now hundreds of buildings that have been built and demonstrated. I think Amory Lovins once said, if it exists, it must be possible. So we know you can do this, and this over a range of climates and building types. But there are 5 million commercial buildings in the US, and 100,000 get added every year. And if we're only doing a couple hundred in net zero, we're losing ground, we're not gaining ground. So we have to change something here. And that's partly what this session is about. And Singapore is trying to do this at scale with a somewhat more constrained kind of package than we have in the US with the variability in climate and so on. So if you think about what the challenge is here, I'm sort of arrayed along 2 scales here. We want to reach all buildings on the horizontal scale. We know how to do that now. You can hire an ESCO, come into your building, tinker with the HVAC, and save 5–10%. The problem is that 5 or 10% isn't enough. At the left-hand side of the scale, going vertically, we know how to do net zero buildings. So that goes all the way to the top. Where we want to be is in the upper right piece there, where we touch all buildings and we get net zero or near it. You can't actually get all the way there, and John is going to talk about that in a minute, but you can get most of the way there with most of the buildings, and that's the important part. And you know, the focus, a bit of the focus on net zero is energy, excuse me, and carbon, but as the green piece shows here, we're talking about comfort, health, productivity, all of the other major important drivers in the building. Now, it's tough enough in the US and California even, it's tough even though the climate's relatively mild. We've got a fair amount of solar in most places, temperate climates where you can do trade-offs. Relatively cheap land, I should be careful about saying that in Boston and San Francisco, but relatively cheap land and good solar access. If you live in a hot, humid climate where you have cooling 365 days a year and land is even more expensive and limited and you're building up, you have a much bigger problem. And this is the problem that Singapore is challenging and working on. So what I'm going to do now is go through 7 quick, sort of 1 or 2 slides each topics. These are some of the issues and challenges that are out there in order for us to get to this net zero solution. The first one is how we define it. The California definition is net zero on the property, on the boundary of the building. That makes it really tough. You cannot build a 40-story high-rise, call it hospital in San Francisco or anywhere, and make it net zero on its site. If you make it the city block or further out, then you've got some flexibility. So there's a lot of definitions out there. One of the ones that Europe has adopted is nearly zero. So, you know, don't worry about if you're 6% or 3% above or below. Just get in the right ballpark, and if you do that in all buildings, we're much better off. So paying attention to the boundaries of doing energy accounting is important. Lots of technical papers written about this. Policies differ, but if you see some of the confusion in the marketplace, it's because people are defining these things differently. Second, again, I keep talking about energy and carbon, but in the end, it's about people. And we need to come up with buildings that work for people as well as work for low carbon solutions. But one important part of this is a big piece of the load. When you take care of heating, cooling, and lighting, a big piece of the load is what's classically called plug loads in the buildings, or miscellaneous use. We're miscellaneous users, I guess, and we use things in buildings. Now, the nature of work has changed in buildings. It will continue to change. We need to pay attention to that. Comfort is an important driver here. So we need to be thinking about providing environments for people as we're looking at this challenge of minimizing energy use. The pragmatic reason for doing this is the bottom there. People cost roughly about 100 times the cost of energy. If you look at the per square foot cost in an office building, my salary is about 100 times the energy use of the space I occupy. So if you don't care about people, but you care about money, you should still be paying attention to people. Putting my research hat back on, innovation and R&D is clearly an important part of this. This is an interesting challenge in Singapore, hot, humid climate. I've sort of flagged a couple of examples here focusing on cooling. one of the challenges they're going through now is that cooling criteria are often based on things that were developed many years ago in other types of climates. So you're really looking at how do you keep people comfortable, not how do you maintain 72 degrees or something like that. The conference they sponsored a few months back, they asked everyone not to wear jackets and ties and ramp the temperature up a little bit, equal levels of comfort. We didn't all look quite as good as we might have, but saved energy. So in this case, in cooling, one of the areas I've worked on a lot is envelope loads. You know, how to use smart glass for smart shading and daylighting to reduce all these loads. In the end, in a climate like Singapore, you're going to have a lot of cooling, and being clever about how to deliver those services, cooling services, is really critical, and you'll hear some about that in John's talk. One of the things we need to do as we get into systems is demonstrate that these things work as systems. I can screw in an LED light bulb, and I pretty much know how it will work. If I put automated shading, dimmable lighting, and radiant cooling into a building, how's that going to work? So before you build it in a 1 million square foot building, it'd be nice to test out the full integrated system. And one of the things we've worked on with Singapore are test labs. The one in Berkeley is called Flex Lab, and Skylab, you're going to hear a lot more about that later, where you can bring in all the pieces and parts, including people, try it out, make your mistakes at the level of 100 square meters or 1,000 square feet and not at 1 million square feet. Here's an example of one of our tests going on in Berkeley. We're looking at cooling thermal comfort here, radiant panels, ceiling fans, and we're generating. So what we want to do here to make it accurate is we want to generate as much heat from computers and people as you would in a normal space. But you see, we've got these really nice people here who never take bathroom breaks and never complain and don't get paid much, but they generate as much heat as you and I do, about 100 watts. Tools, process, education, and training. This is a huge area, and without this, all the technology in the world isn't going to do us much good. So you need a lot of architects and engineers in the room. I don't know how you're feeling about the tools you're using and the data you have available to you, but these are real challenges. BIM is an issue. Managing information is an issue. And we could spend the entire time here just talking about process issues and tools and data. This becomes more critical as the performance levels you're trying to achieve become greater. And I've kind of packaged that here as a life cycle view, because what makes this even more challenging, I mean, in the good old days, you designed your building, you did your code compliance, your LEED compliance, you were done. Sometimes the buildings worked, sometimes they didn't. We all know that. But what we're looking at now is buildings that demonstrate real performance, again, energy, carbon, and for people. So you've got to look at all these different issues. You've got to look at the construction side, the operations side. You know, I left off one really important piece here, just to see if you guys were awake this morning. What's missing here? Value engineering, right? That's the killer, right, okay. Well, that's also why I left it off. Shouldn't be there at one level, but we all go through it, and that's when someone says, uh-oh, building's more costly than it was supposed to be, I'm going to take off all that nice shading because I'll save a lot of money, or I'm going to change. Anyway, a real issue, a real problem. If you do this right, value engineering is embedded real time into the whole thing. So a net zero building is going to have a renewable source, and it's going to probably talk to the grid because you're probably not going to be off the grid. These are two really important issues. On the positive side, the cost of PV systems and wind as well have gone way below. I mean, they've dropped much faster than anyone anticipated. That's great. Challenging issues about how you integrate it into a building. I mean, if you've got lots of open space, you can put them in all kinds of areas. But if you've got tight urban environments, then you have to pay attention. And if you're at the equator, it took me a while to get used to working at the equator, thinking about the equator. Where's the sun in the middle of the day? And east-west versus south. I mean, I spent 40 years talking about the south is the best place to get solar and so on. Well, not so at the equator. So figuring out how to integrate the collection of energy appropriately. And you could cover the side of a building with PV, but then maybe you can't see through it. So we're back to what people want and need. So this is a big challenge. And the other reason it's important is sort of this slightly complicated diagram here. You know, on the red box on the left is the space that we occupy. And the consequences of lighting, cooling, and envelope in that space ripple back into other parts of the building, into the chiller, and then ultimately back to what has to be provided either centrally or on site. And I always get caught in a situation when people say, oh, that's smart glass or that dimmable lighting. It's too expensive. It's not too expensive if you can reduce the chiller and reduce the PV and then take the money and move it back into the building. So you can only do that if you have confidence that all this stuff will work as a system. Almost through here. it's fun to talk about new buildings, clean slate, but in the real world, a huge fraction of our building stock, well, at any given moment, 99.9% is there, and even over 10, 20-year timeframes, most of the buildings we'll be using and most of the buildings that will be using energy are there now. So we have to figure out what to do, and the classic term here is deep retrofit, or making them NZE ready, net zero ready. The good news, again, is there are examples, an example here in the US and in Singapore, I think you'll hear more about later. It is possible to do this. There's a different set of challenges, but they overlap with the new construction. A lot of interest in this in Europe because, again, a large building stock there as well. So there's activity, there's interest here. Some of the things are the same, some of them are different that you have to worry about. And then finally, if you're going to do this at scale, you need programs and policy. And not my invention, but this big, hairy, audacious goal BHAG is something that's been used in business schools for a while. I think it's a useful way to sort of step back and think about this. I don't think we're going to solve this problem by incrementally chipping away and doing what we did last year slightly better. So someone needs to step back, look at the challenge, look at the opportunity, look at the pathways to get there. And I think you'll be excited by what you see in terms of Singapore. I get a bit frustrated in the US because we're so diverse and scattered. I mean, at any given point, there are cities in the US and some states that have policies vaguely like this. Because we work at a national level, if you step back and look at what's going on nationally in the US, it's a chaotic jumble of things. Doesn't mean there's not great stuff going on in different places, but bringing all that together into a coherent program is a real challenge. And then executing that, putting the resources there. You can't do this sort of one day on and one day off. If you think about this 3 cycles, I mean, if it takes, 3 to 5 years to do a medium-sized building from starting planning to when it's occupied, and we've got these 2030 goals, we've got 13 years left. We've got only 2 or 3 cycles. In the software world, people say fail early and often. You don't want to do that with a 1 million square foot building. Or if you fail, you want to fail at those test labs and then get it right. So you want to carefully think through all these programs to implement them at scale. So my last 2 slides are, if you're going to do that, you need a balanced program. I'm an innovation guy, a research guy, but all the R&D in the world, the technology in the world by itself is not going to change things. So some combination, markets, policy, people, technology is needed. The actual mix depends on the details of what you're working with. But if you don't have that mix, invariably, you aren't going to reach the goals that you have. And then finally, this is a quote I picked up a while ago from Henry Ford. It is frequently, I think, sort of a lack of vision. Again, we tend to look at the problem out there and tend to want to make it slightly better. Maybe that's human nature. But I think what we need to do now is step back and say, where do we need to go? What are the challenges? And put these big plans and programs into place. A lot of activity in Europe, a lot of activity in the US. That's good. I don't think that any of the things I've seen in the US and Europe are on a pathway that will guarantee success. I don't think actually we can say that about Singapore either, but it has even greater technical challenges and they've got an interesting program. So for the remainder of the session here, we'll take a closer look at that. So I'll invite John to come up and continue the discussion here. And save your questions for the end here.
Thank you very much. Well, good morning, everyone. Can I just pick up from where Steve left off? And before I cram our 12 years of green building movement in Singapore in 10 minutes and share all this with you, can I ask all of you one question by show of hands? How many of you heard of Singapore? Excellent. So I don't have to spend so much time talking about Singapore. Well, we always are very proud of ourselves with a little green dot in the tropical belt. This is what I'm going to do today, to share with you these 3 areas covering our 12 years of green building movement in Singapore. I always want to compare Singapore with New York City. We are about the same size, less than 300 square miles in size. Of course, there is a key difference. Singapore is New York without the United States. And Singapore is New York with summer all year round. We don't have 4 seasons like yourself. We are hot and humid. In the last 50 years or so, ever since our independence, I think we have transformed Singapore into a modern metropolis it is today. And I believe that we are probably enjoying one of the highest GDP per capita in the world as a city. But here I do want to emphasize very clearly from day one that other than economic growth, one of our key objectives 50 years ago when we became independent is that we want it to be sustainable. We took sustainable development very seriously. I've been working in one of the biggest residential developers in Singapore. We emphasize a lot of natural lighting, natural ventilation in our design. So green building is not really so new to us. Of course, I must say that in our case, we do have very different challenge from many cities in a temperate climatic condition. You see, before 2005, when we developed our own green building evaluation program, we call it the Green Mark, and it is designed, tailor-made for the tropical belt, subtropical belt. Before that, we've been doing a lot in our building design to make sure that the heat gain into our building is minimized. So we need less energy to cool down the building. But since 2005, when we have our Green Mark program, we have gone through 3 successive master plans with different focuses. We focus firstly on some of these low-hanging fruits. New building, we want it to be as green as possible from day one. After that, we progress to look at retrofitting existing buildings to see how far we can go to make them as green as possible. When I say green, I mean not just energy efficiency. I mean water conservation, good indoor environmental quality, reuse, recycling during the construction process, and of course, many other ideas that help us achieve extremely low energy consumption in our buildings. The last phase started in 2013. After moving from new building to existing building, we focus on the user, people like you and me. We believe strongly that user has a big part to play in getting our building green. So we have been doing quite a bit of work with people who use the building, office worker, residential, young people, and so on, to make them understand that they can make a difference in going green. So for the last 12 years, starting from almost zero base, looking at green building comprehensively, this year we have reached a milestone. 1/3 of our entire building stock in Singapore, which is more than 1 billion square feet in terms of floor area, has been certified green under our Green Mark program. And we have not stopped here. We have shared with many countries and cities in our region to help them to understand the need for their buildings to go green. So we have projects in 80 cities in our region, China, Malaysia, and even as far as Africa, Tanzania. And we have also worked with the United Nations Environment Program to help some of the regional governments to look at their policies, look at their strategies in getting the built environment to go green, to be as energy efficient as possible. As Steve said, we face quite different challenge at the technical front. I do not want to cover that too much. I want to share with you at the people front, the industry, the user, the kind of challenges we face. So 12 years ago when we started, one of the big challenges is that our industry is not very sure whether there's any value in green building. What they're concerned about is cost. How much more you have to pay to get a building to go green. So we decided to do a few things. One is we believe that as government, we must walk our talk. We cannot be just talking and not doing anything. So we decided that all our new projects, since 2008, must achieve the highest level of green building certification. And we have also made sure that our existing building would also be green by 2020, achieving the second highest level of certification. We have set up many funding schemes to kickstart this process for the private sector. By now, we have set aside close to 130 million US dollars to get our building owner, our developer, to go green. And we have also spent a lot of time looking at green building projects. How to convince our owners, developers, and the users to understand the strong business case for green building. So over the years, we can see the payback period being shorter and shorter. But that's not the only challenge. The other challenge we face is that even if the building owner and the developer wanted to go green, but is the industry ready? Do they know how to design, build, operate, and maintain a green building? Without this capability, I don't think there is any possibility for any legislation or incentive to work. So we have set a very ambitious target. We want to have 25,000 green-collar workers by 2025. So far, we have trained 16,000, about 2/3 on the way. We also believe that you can use incentive, you can use legislation to kickstart the process. But if you want to sustain the green building movement, you must raise the awareness of the people, particularly the user, because the consumer, they are the one who can sustain the green building movement. So we spend a lot of time having all kinds of programs to get our young people, to get the public, to get the office worker, to get users of building, understand the need for them to contribute to this whole movement. Well, I want to spend a few minutes on our zero ambition. We have retrofitted an existing building in the BCA Academy about 10 years ago, started thinking about having a zero energy building. And we have been operating this retrofitted building for about 8 years now. And I must report to you that we have done better than expected. We have generated more electricity, full solar panel, than consumed, 8% more every year. And we have focused a lot in this project on how to make good use of passive design and improving your active system, your M&E system, and so on and so forth, to drastically cut down energy consumption. So for this project, we have cut it down by half what we would have needed to run a building like this. We are not going to stop here. There are many other projects, and one of them is going to share by Prof. Lam later on. It is a 5-story building going net zero. And there are quite a few of these projects going on in Singapore. And for this first retrofitted zero energy building in the BCA Academy, we are not going to stop at 8% positive. We are going to have a second retrofit exercise to see how far we can go. And we set a target for ourselves. Can we achieve 40% positive, generating 40% more energy than they consume? The way ahead, this is our ambition. It's a very stretched target. We want to see how far we can go to get low-rise building, say up to 4 or 5 stories in Singapore, to have positive energy. And we also want to see whether we can have medium-rise building, 10 stories or slightly higher, to have zero energy. And of course, Singapore is a high-rise, high-density city. So we also want to have a high-rise building, say a 20, 30, 40-story building. Can it achieve super low energy, better than the best-in-class building in Singapore today? The other area we have done quite a bit of work in recent years is that we believe we can only achieve this stretch objective by looking at technological breakthrough, innovation in our design and in our planning of our landscape. So we have set aside about $40 million for this R&D program to test bed many of these new technologies, new design that we want to implement in a tropical belt. And we have worked together with Steve, the Lawrence Berkeley National Lab, to provide a facility to really stretch the envelope, to see how far we can go by changing the facade design, by integrating various systems to achieve our target of positive energy low rise, zero energy medium rise, and super low energy high rise building. This test lab operation is operational since last year, and we have R&D project lined up to end of next year. Well, my final slide, that's what we want to do. By 2030, in 13 years' time, we want to green 80% of our entire building stock in Singapore, certified under our Green Mark program. We want to see how far we can go to have this positive, zero, super low energy building for various types of high, medium, and low-rise building. And of course, we do want to share all this experience with countries in our region to see how far they can go to do their part for the environment. Thank you very much.
All right. Switch over the. Good morning, ladies and gentlemen. Good morning. Hope you're still feeling awake and energetic. Good. Are the slides going to be coming on, or do I just continue? I just forward. Great. All right. So, as a lead on, sustainability, as we all know, is about preparing for the future. And much of the challenges that John has talked about really lies in the education and training and research programs in order to provide the kind of manpower, the kind of knowledge base and skilled workforce to really realize a lot of those goals and ambitions. And that's where the National University of Singapore comes into play. NUS is the oldest comprehensive university in Singapore. It's over 100 years old. And our School of Design and Environment, which has different names in the past, is almost 50 years old. And we are the only comprehensive sort of school that trains, educate and train professionals for the construction industry. Within the School of Design and Environment, we have the Department of Architecture, Building, Real Estate, and Industrial Design. And architecture, until very recently, 6-7 years ago, was the only school of architecture in Singapore. And so everything you see in the landscape today, as has been shown by both Steve and John, would have had the handiwork of our graduates. 6-7 years ago, SUTD started in partnership with your neighbor here at MIT, with another school of architecture that has now started to produce more architects for the much-needed industry. The Department of Building, in architecture itself, we have both programs that cover urban design, urban planning, landscape architecture, as well as the professional architecture program. In the Department of Building, we train construction management, facilities management. We do building performance and diagnostics in that particular department. And in real estate, we focus on planning, land use, also economics as well as finance as one of their strengths within the department. And then we have also industrial design that looks at the products, the end-use products, serving a whole range of industry, including the retail market. We are particularly well known for the cosmetic industry. We have support and sponsorship from people like L'Oreal, Guerlain, and Shiseido, names that you're familiar with, as well as Airbus in France. We do work related to the aircraft industry, all the way to the healthcare industry. We do a lot of products for the healthcare. For example, the disabled people, how to have products that will enable them to live independently are some of those pursuits in the industrial design area. So we are a comprehensive school, and that provides us with a lot of opportunities to really encourage the students to learn together and understand and collaborate in a positive way to drive all those goals and innovations that have been stated. So a quick use of this SD4, we call it, this new purpose-built, the first one, purpose-built net zero energy building in Singapore, gathering from all the experiences that BCA has done together with our colleagues to really bring it to bear in this new building as a living laboratory for all our students to collaboratively learn and work together. So this is a campus map on our part of the, so this is the new building. My office is right here, so for the last year and a half, I've been literally living on a construction site, which is all very exciting. So this is a south elevation, just to give you a sense of what it looks like. And immediately you can see some of the very obvious features that has been talked about as we evolve the idea. Now, this is of course done in close collaboration between the end users, which are us, and the design the team. I think that's a really important criteria to get good outcome, is to really learn about what is the real use of the building and what the purpose and the objectives, in order that the design team truly appreciate and understand what is often a very complex program of activities. So starting from the base case, the development of the language and platforms and forms is really to continue to support and to promote many of the features that have been mentioned that are critical in the tropical condition. How do we maximize passive design to allow for lots of opportunities for natural ventilation, a lot of transparency in our buildings, as well as providing great shading. Shading is really a very fundamental element in designing in the hot, humid tropics. How do we shade from the sun? So the roof feature is really very important, and then the screens, both in the east and the west facade, to really create another layer of a passive sort of approach to reducing the solar impact on our building. Some of the key climatic response features for this building. And here you see a picture of the screen on the east elevation. In terms of the space and form, we need to really understand the use of the space in a very dynamic and ever-changing way, because this is a university, an educational institution. Our curriculum are constantly being reviewed and revised, and to continuously try to promote, as I said, cross-disciplinary research as well as teaching. So those spaces need to be generated in a very dynamic and flexible way. So the education model is really derived from that, using a lot of wraparound circulation spaces for students to have breakout spaces to encourage spontaneous sort of a discussion and interaction. And then you have a central study platform core where the design studios are. These are for architecture as well as industrial design, where the students have a very nice and wide open space to adapt to different kinds of project setups that are necessary. And at the same time, creating lots of community spaces, green community spaces like the front garden and the terraces that we want to provide up on the roof as well. The first one about wellness is also an important characteristic. How do we engender this feeling of wellness? And one of the ways is really to be able to connect a lot more to the outside, to nature, and to be able to look and appreciate all the different activities that are ongoing within the space in a very transparent, as I said, and very dynamic way. So that gives us a sense that there's a vibrancy in the academic environment, as opposed to, I'm sure many of you have experienced traditional traditional educational spaces that are all boxed in and very often windowless. We need to get way far away from that kind of situation to really spark the next sort of generation of creative designers. So here are the sort of a cross-section from both the longitudinal and on the north-south facade. As you can see, there are really lots of interconnectivity between the spaces, allowing for dynamic movement, both visually as well as physically. And here is, for example, a social plaza that really will engender that kind of collaborative activities whilst connecting out with nature. NUS is a very nice site. It's in a little hill. We call it sort of Kent Ridge. And it really has a good view to the sea on the west coast. So it's a really very nice setting with a lot of lush greenery around the place. So here are some breakout and circulation spaces images that I want to show you. And this is what a studio would typically look like. And to be able to have, as I said, those very transparent and a very kind of dynamic setup. And of course, it's not just about the digital as well as the kind of studio-based, computer-based work, but we also encourage making. I think sometimes this is something that we have neglected. We have kind of gone so digital that we have neglected to get the students to, engage in the process of making and build, some real stuff as part of their learning experience. So we've created some of these outdoor spaces called test bedding to enable them to do that, to get a feel of the real materiality of things rather than constantly staring at the computer screen. This is really, really critical, we believe. And even in the lecture theater, you can see that there's a lot of kind of interactive transparency. So the energy reduction strategy, John has talked about this quite a lot. We basically apply the same technology, the same concept. How do we keep reducing the energy consumption using passive design methods, drive it all the way down in order to then be able to be met, the energy demand will be able to met with the PV production that are provided on our roof. So it drives quite significantly down, as you can see. And even then, we are constantly tuning the kind of way to manage the controls of the buildings, because one of the sort of critical feature to enable that the net zero can continuously be maintained is really to make sure our systems are operated correctly and as designed, and make sure that the occupants understand how to live in this net zero energy building. That's kind of education process. So one of the major primary ideas is what we call a hybrid system, whereby we do maintain air conditioning with the VAV, but with 100% outside air. But we raise the temperature, the set point temperature, to about 26.7, which is 80 degrees Fahrenheit, which is a really comfortable summer temperature, right? There's nothing wrong with 80 degrees. You all would enjoy 80 degrees. And we will bring the humidity down slightly to about 65 to 68% RH. But we enhance the ventilation with fans. It's not a new invention by any means, right? Fans have been around forever, but it's just that we've forgotten about that. So we're bringing this all back and combining them in order to create the kind of adaptive comfort condition for our space. Now, it's all very new certainly to the folks, today. So we set up test beds even as the construction is going on. We set up test beds in some of our seminar rooms in order to actually do measurement and see whether we are able to achieve those kind of performance. Just as has been said by the other colleagues, we do both daylight as well as the thermal measurement. But importantly, people. We got to bring the people in. When this whole idea of a hybrid system was first suggested, the immediate reaction from many of my staff was say, "You mean there's no more aircon?" That was their immediate reaction. We said, no, there is aircon, just it's not the usual type of aircon. And so we bring people in there to our test bed even as we are developing, and happily, majority are in fact feeling good and comfortable within those test beds that we mocked up. So as you can see, it's over 80% to close to 90% who felt that it is in fact comfortable. So we are very confident now that this system will actually do well. Construction is going on, as I said. This is literally looking out my window from my office. And what's next? Next, of course, we need to continue to focus on the people, because people-centric design is really the key for the future of sustainability. So this wellness is going to be a big challenge for us, and we're going to use this building as one of the test beds for getting the WELL certification as well. And so work is ongoing on this. so that we really would combine this whole idea of wellness and green buildings together. With that, thank you all very much for your kind attention.
So thank you guys for coming a long way to share your stories. It's great. Really appreciate it. Window to wall ratio, one of the first big issues we face a lot. Developers think tenants want all glass windows before they have tenants, whatnot. But how do you see addressing window to wall ratio? I know in your last project there, the north or south face had all glass, or west face, but you did have some shading. But the low R values and whatnot, how do you address? What do you think the level of importance of reducing window to wall ratio is in tackling this issue?
Can I just try to answer this question? I think even before we embark on our Green Mark program, we have been paying a lot of attention on all these design parameters, including this wall and opening ratio. And I must say that we take it as a minimum requirement that you must meet as a good designer to minimize the heat gain in our tropical climatic conditions. And I think we have been doing this for the last at least 30, 40 years. So I believe our Singapore architects in the audience would probably testify to this, that is one of the basic premises when they design a building. It is critical.
So I'm going to add a slightly different take on this, more broadly than just the projects you see here, and that is that the classic 30-40% code minimum stuff comes from the fact that windows historically have been very good, single and double glazing. But it's 2017. We can do far better than that. We can produce windows that the window itself, the envelope itself, is a net positive. You can reduce the heat loss to as low as you want it. Triple glazing, quad glazing, low E coatings, there's all kinds of options out there. You can manage the solar gain and glare with electrochromic windows. There's some on display out front there with automated shading. And the reason to think about keeping the window to wall ratio at some reasonable level, of course, is partly the daylight, but increasingly its view, its connection with the outside, it's triggering your internal mechanisms so you don't get enough light to be awake at the right time. So in the last decade, and I ran the windows and daylighting program for 30 years at LBL, we can demonstrate, we've built and demonstrated at scale solutions that really work. The problem is either the architect engineer team doesn't conceive of them properly from the beginning, or they do a great job, and remember that old value engineering problem, all that nice stuff that makes it work gets dropped out, and then you end up with an all glass building that doesn't work worth a damn. So there are solutions out there. They cost a little bit more money now, but in the scale of the whole cost of the building, it's easily achievable. And I think that the last comment I would make is that I can talk to a manufacturer about what they should do. They're going to say, what does the market want? So if you all don't ask for those solutions, cost-effective, viable solutions that work in the real world and provide comfort as well as efficiency, then we'll just stay stuck in the rut that we're in for a long time.
If I could add a quick, I think this concept of window wall ratio has got so entrenched in respect to the way we design that it has to be a box. That's why we have window and wall ratio. Whether it is all solid or all window or all glaze, it's still a box. I think what we're trying to experiment and explore is to really begin to change that parameter of what is a wall, what is a window, what is an opening, how do we encourage that kind of transparency and that kind of passive, as you can see, passive approach, that this notion of window wall is no longer so well defined. And I think we need to think more in those kind of contexts rather than still maintaining that conversation within a box, whether it's glass or solid.
And you could see that in your design because you had a lot of outdoor spaces, which works perfectly well here for about half the year, which works in Berkeley most of the year, but there's certainly parts of the US where you're not going to do that. Other questions? Yep, just...
Do you find that, thank you for your presentation, do you find that energy analysis software is up to the task of doing what you're trying to do, with using a BIM model and doing an energy analysis? And If so, which ones do you like? And if not, what would you like to see in energy analysis software?
Well, I've been doing energy modeling for 30 years, starting with the good old DO2. You remember those days where we had to codify everything in text form? I still believe in that because by doing that, you really get into the essence of energy modeling and not just dragging and dropping stuff. I think in the digital world today, we have this challenge. The tools today with all the interface and fancy kind of approaches sometimes neglect the fundamental science and physics of energy modeling. And one very fundamental thing is about zoning. We still don't quite know how to do our energy modeling zoning correctly. And therefore, it has this consequence of half of them being right, half of them being wrong. And I think the technology, the tools themselves, the fundamental algorithms that DOE, for example, in Energy Plus and so on, are really rigorously tested. We just need to educate the folks who are doing this model to use the tool appropriately, and you will be able to get the right results. And make sure the design follows the model. You didn't do all your model you like if the constructor, the contractor doesn't follow it and link up all the zones into one zone. Don't blame the model, right? It's not the fault of the model per se. So one of the buildings in Singapore that I did, the National Library building, back in 1998, we were able to get to within plus minus 5% accuracy, operated. And now it's been in operation in more than 15 years. In fact, it has dropped another 10% or so compared to the as design. So when you do the models tell you what are the right strategies to use and make sure those strategies are carried through. I think that's important.
I would just add that I would agree with everything Kipo said, and we do a lot of model development in the lab. I hope you use Radiance and Energy Plus and window and thermal optics tools like that. But the key issue also is when are you using them and who's using them? So a tool used in concept design is going to be used differently. You're going to put different information in, expect different outputs than a tool in detailed design or in lead compliance or code compliance. So paying some attention to what problem you're trying to solve, what degree of knowledge do you have about the building at that point. There's no point in having a very complicated, messy, sophisticated model if you're dealing with a box in early design. So being able to tune the use of the model to where you are in the design process is critically important. And tools are getting better along those lines all the time.
I must add that in this process of modeling, the more critical part is really to follow up, as what Prof. Lam said earlier on. We have seen many projects. The modeling we thought was very good, but what the outcome is not so. But in our case, because we do have a strong verification process post-construction in Singapore, so we do see many buildings, after going through this modeling process, they do perform better than what has been modeled.
Another question?
Thank you. First of all, congratulations and kudos to you all for your green efforts. You mentioned in last approximately 15 years, 1/3 of your buildings have been transformed to green buildings. In this transformation, have you observed or recorded any decrease in power generation and or increase in wellness and health of human beings or of the occupants of the buildings?
Sorry, I don't quite get it.
Power generation,
Has it significantly reduced since you are consuming less in the health and wellness of the occupants?
the supply side?
Well, I suppose if you look at the overall consumption, it is at quite a steady level, although there's an increase in building floor areas in our case. But if you look at specifically on those buildings, that 1/3 of those buildings has been green, even though the floor area has increased, but the actual consumption has reduced. And if you compare specific buildings, a green mark building normally can perform at least 15% better than a non-green mark building, other things being equal.
The health and wellness of the people
Health
in the
and
building.
wellness.
Are you measuring any of that? Or?
I think it's still early days.
Very early.
We have incorporated many of these wellness ideas into our Green Mark program. So in our case, instead of having two standards, we are integrating everything into one single standard. And our Green Mark program today is undergoing the 5th revision to incorporate all these criteria into our assessment program.
If I can add, the current has been most emphasized in the built environment's thermal comfort. That's the thing that has come a long way. Wellness is still very, very new. The way we appreciate or understand wellness is still through very superficial kind of survey. We need to do a lot more with the medical community, I believe, to really get into the reality of what it means to be healthy and to feel well. That is really, from the construction industry point of view, is just beginning. We have a long way to go.
Anyway, over time, I must say that to convince the user to do their part to go green, health and wellness is probably one of those trump cards that you can throw at them, in addition to energy consumption, as people are getting more and more concerned about health and well-being and so on.
Correct.
I think we have time for one last question, perhaps.
Yeah.
Go for
So
it.
thank you for coming to speak this morning. My question is about the more rigorous certification program, so Living Building Challenge and Building Well. I think that LEED is going to be a standard benchmark. So how do you see Living Building Challenge and Wellness being incorporated into urban planning and building design in the future, and the challenges with that?
I suppose one of the key concerns we need to address going forward is really that many of our, as far as I know, many of our green building evaluation standards in many cities does not really have rigorous verification process post-construction. And in our case, from day one, we have been paying a lot of attention on what actually built on site and how it performed after a year or 2 years or 3 years, to make sure that whatever you design, whatever you promise in your design, can be measured and as an outcome. So it is probably quite important for us to do a lot more here to make sure that whatever is designed would be built accordingly and it perform according to whatever has been designed. And this is really one key area that we need to make sure it is done. And I believe that in our case, maybe we are a bit fortunate because the Green Mark program is run by a government agency. So my organization is not just a promoter, champion of the industry. We are also the regulator. So if you don't build according to design, you won't get your building permit.
So I think we'll close on that thought that I think in the U.S. we have LEED, we have Living Building Challenge, we have wellness, we have a lot of things that are in place now and coming. And in some sense, Singapore is a test bed. They've put the package together. They're improving it all the time. They're trying it out. I've been interested in being engaged with them because we're learning something from them. And so I think we should continue that good exchange and process. So with that, I think we'll keep you on time and let you go on to your next sessions. Thanks very much for your
Thank you.